last time we have studied about nomenclature of alkane, and in this video lecture we will discuss about alkane and different methods to prepare alkane. First of all, what are alkanes? Alkanes are hydrocarbons. These are hydrocarbons in which one carbon makes single bond with another carbon atom, in which carbon atom makes single bond with other carbon atom and we can say all carbons are sp3 hybrid. All carbons are sp3 hybrid. sp3 hybrid, and their general formula is CN H2N plus 2. CN H2N plus 2. Alkanes are also known as the paraffins. These are also known as paraffin. Why alkanes are known as a paraffin? Because they are least reactive, so we also name them as a paraffin. And the simplest example is methane. Simplest example is methane, CH4, and methane is also known as natural gas. Methane. Now, general methods of preparation. First of all, we can prepare alkane from alkenes or any unsaturated bond, carbon, double bond carbon. So, naming the first method as hydrogenation. Hydrogenation of alkene or alkyne. We can prepare alkane from alkenes and alkynes by hydrogenation. Next method is from hydrogenolysis. Hydrogenolysis of alkyl halide or we can also form alkane by the removal of halogen atom by reacting alkyl halide with zinc. Reaction of Zn in the presence of any acid like HCl, in the presence of HCl with alkyl halide. reaction also yields alkane. And fourth method is decarboxylation of monocarboxylic acid. Decarboxylation of monocarboxylic acid. We can remove carbon dioxide from monocarboxylic acid in the presence of sodium hydroxide, and catalyst is calcium oxide, and when we heat these three things, it forms alkane by the removal of carbon dioxide. Next method is, fifth method is Kolb's electrolytic method. Kolb's electrolytic method. It is very famous method for the preparation of hydrocarbons like alkane, alkene and alkyne. In this method we use salt of any carboxylic acid. If we use salt of monocarboxylic acid, then it will form alkane, and if we use salt of dicarboxylic acid, then it can form alkene or alkyne. Next method is by reduction of aldehyde or ketone. We can also form alkane by reduction of aldehydes and ketone. And last method is by Grignard reagent. By Grignard reagents. Students, now moving towards the method that we mostly use for the preparation of alkane. First method is hydrogenation. Hydrogenation. What is hydrogenation? Simply we can say that it is the addition of hydrogen. It is the addition of hydrogen. Addition of hydrogen and this addition is in the presence of any catalyst, in the presence of catalyst, and we use mostly nickel, palladium or cadmium as a catalyst. The main catalyst is nickel. Why we use nickel? Because nickel is a cheaper catalyst, and we can also use palladium or cadmium. Palladium and cadmium are expensive catalysts, but for the effective hydrogenation we can also use nickel as a catalyst, but it needs higher temperature for the reaction. In this case we convert alkene or alkyne into alkane. First, I am taking alkyne, carbon, triple bond carbon, and here will be any group. I am putting just alkyl group. You can use hydrogen, CH3, CH2, CH3, depend upon your own choice. I am hydrogenating it in the presence of catalyst like nickel, and the temperature will be 200 to 300 degrees Celsius. When this reaction ends, it forms alkene. Carbon double bond carbon, alkyl group. Here is hydrogen and here will also be hydrogen. Up to this step we can name it as a partial hydrogenation. And when we add some more hydrogen to this reactant, then this product will convert into alkane. R group, carbon, hydrogen, single bond carbon, hydrogen, and here will also be alkyl group. It is a complete hydrogenation of alkyne, or we can say that we are doing hydrogenation of alkene, and when we perform hydrogenation to any alkene, it will convert into alkane. We can write here as a positive plus sign. We are adding one hydrogen molecule, 1 mole of hydrogen to other alkene. Next method is decarboxylation of monocarboxylic acid. Monocarboxylic acid. What the term is telling us? Decarboxylation. Decarboxylation is that we are removing carbon dioxide. It means that we are removing carbon dioxide from the reactant. D means removal. It means removal. Carboxylation, CO2, removal of CO2. And in this we use sodium hydroxide, NaOH. It is used as a reactant or reagent. Calcium oxide CaO is used as catalyst, and when we add these three things, just we have to heat the mixture and it will form any alkane. For example, if we have monocarboxylic acid or C double bond O, OH, and here is NaOH. In the presence of catalyst CaO, and by heating it will form any alkane or H, and side product will be NaHCO3. NaHCO3. Sodium bicarbonate. It will form NaHCO3, and it will form RH. RH is any alkane. When we remove one hydrogen from alkyl group, one hydrogen from alkane, it forms the alkyl group, and when we add any hydrogen to any alkyl group, it forms alkane. Next method is by Grignard reagent. By Grignard reagent, we know that Grignard reagent is R, Mg and X. we can form many things from Grignard reagent, and when we react Grignard reagent with water molecule, it forms alkane. When we react Grignard reagent with water molecule, it forms alkane. Or MgX plus HOH. It is partial positive, partial negative, and it is partial negative, partial positive. We know that the bond between alkyl group and magnesium is reactive, and it will pick hydrogen atom. It will pick hydrogen atom, and this hydroxyl will attach with this magnesium atom, and the resultant product will be alkane or H. It's alkane and MgX and OH. I hope that you have completely understood these three mechanisms. Now moving towards the most important preparation method, that's cold electrolytic method. Cold electrolytic method. I am going to erase this portion. Cold's electrolytic method. In this, we take a cell or beaker like this, and we add our reactants in this solution. The solvent is H2O, and we add carboxylic acid as a reactant, and after that we also add 2 electrodes in this solution, and we connect these 2 electrodes with batteries. First become anode and second become cathode. What happens in that mixture? If we have monocarboxylic acid or single bond carbon, double bond oxygen, OH, and this reaction is being occurred in water solvent. When we add carboxylic acid to water, it ionizes itself and forms 2 types of ions. First is R carbon double bond oxygen, oxygen negative, and second ion is H positive, negative and H positive. And when we connect those 2 electrodes with electrical source, then we can say one electrode becomes cathode and second becomes anode. If we write it as a cathode and its anode, cathode is negatively charged and anode is positively charged. And here are negative ions and positive ions. Now these negative ions will move toward anode, and these positive ions will move toward cathode. Positive ions will move toward cathode. And if we use sodium salt of carboxylic acid, then this hydrogen will be replaced with sodium Na, positive and negative, and here will be formation of sodium ion Na positive. Then the positive ion will be sodium, and if we use just carboxylic acid, then there will be the formation of hydrogen gas, and if we use sodium salt of carboxylic acid, then there will be the formation of sodium hydroxide. And in this case, what will happen? This negative part of carboxylic acid will move toward anode. Then we can say the reactions occurring at anode, so heading it as at anode. At anode. When this anion reaches on anode or carbon double bond oxygen O negative, it loses one electron and converts into radical or carbon double bond oxygen and O radical. We know that the radicals is more reactive species. When it forms in a reaction, it will react rapidly. And in this case, here is a bond. One electron will move in between carbon and oxygen, and this electron will move toward here. Now this electron comes over here. One molecule converts, one part of the radical converts into carbon dioxide, and here will be the formation of alkyl radical. One carbon dioxide will be released from the mixture, and here will be alkyl radical. If we use 2 mole of sodium salt of carboxylic acid, then there will be the formation of 2 alkyl radicals, and when these alkyl radicals come in contact with each other, one electron of this alkyl radical will come over here and its electron will come over here. Here will be one bond between these 2 alkyl groups, and these 2 will convert R single bond R, and it is alkane. Now moving toward the second part, that's occurring on cathode. Second reaction at cathode. Cathode is actually electrode having negative charge. When water molecules come in contact with cathode, water molecule will gain 2 electrons. It will gain 2 electrons and converts into hydrogen gas and hydroxyl group. This hydroxyl group will combine with sodium and convert into sodium hydroxide. Converts into sodium hydroxide. I hope that you have completely understood these 3 reactions for the preparation of alkane. And if you feel any disturbance, if you feel any difficulty, then you can ask. And please don't forget to subscribe my channel and share my videos with others. You can also find the previous videos in description. I have mentioned the links in description. Thank you and Allah Hafiz.